This is a paper with my co-author Junjie Zhu. I believe some of you have heard this presentation by my co-author before. Before I start, I'd like to make two disclaimers. The first one is that I will not be able to provide some takeaway message for MBA students from this presentation. And the second is I will not be able to provide immediate antitrust implications either. But I believe, I hope, this framework that I'm going to discuss will be very useful for us to study antitrust problems, particularly, for instance, if we need to conduct merger reviews involving platforms. And the first step is to try to understand the demand system. And based on our understanding of demand system, we do counterfactual analysis in terms of predicting price increases. So in the context of multi-sided markets, to understand demand system, it is actually quite a challenging task. And if we're going to study exclusive behavior or even abuse of dominance involving multi-sided markets, we also need to understand how customers from different groups, different sizes, interact through the platform. So that is the second disclaimer. Given our discussions yesterday and this morning, I suppose we don't need much motivations for our study of multi-sided market. However, I like to just mention a few keywords that we would like to focus on. One is essentially cross-group externalities, which is a key concept in this framework. And the other is that in some applications, we might have to encounter more than two platforms. And we might have to encounter essentially more than two sides. So if you think about ad exchange, there are more than two sides, typically three sides. And there are so many platforms providing ad exchange services. So that is, and moreover, when we deal with platform competition, deal with platform services, with different platforms, they offer differentiated product, different services. So those are the set of elements that we would like to focus on. Again, from yesterday's discussion, there are so many challenging issues. There are so many tax questions that we won't be able to answer, but they're very important and relevant. For our study, we would like to just focus on a few rather standard questions and the issues, and from there we will be able to say more. So the first question we're trying to answer is, how should we think about platform price competition? So obviously quality and other dimensions are also important. From what we know from practice, from literature, in this area, in this kind of markets, we often see cross-subsidization. So to what extent, what determines the types of cross-subsidization, and therefore we could evaluate the impact of different business performance. Okay, and specifically, to what extent, as the competition increases or decreases, such as merger, such as free entry, and so on and so forth, how would prices change in this kind of setting? So both questions are more elementary in the context of, let's say, oligopoly theory. Moreover, based on our understanding of how competition affect the, for example, prices and so on, particularly we would like to see whether in platform markets, to what extent free entry might be socially optimal or not, in the sense that are there too many platforms in the market or insufficient number of platforms in the industry. And to what extent, if, for example, if two newspaper publishers merge together, with subscription fees, advertising rate go up or go down. And yesterday, during the break, we're discussing about, since we're dealing with multiple sides, think about advertising through newspaper media. After a merger, if the price of subscription fee is increased by tiny or might even go down, but advertising rate goes up, how do we balance consumer welfare since we're dealing with two groups? We're not answering that question in this setting, but from our analysis, we'll be able to compute consumer welfare across different sides. We can try to balance it as you wish. So those are the kind of standard economics 101 type of questions, but we address those questions in the context of a multi-sided market, okay? Because I won't have time to talk about the literature, I'm going to just use this short remark to summarize what is available from my understanding. That is, the literature typically focuses on two sides, and a lot of study on monopoly problems. Even in the case of two-platform competition, the literature focuses on the standard Hotelian specification of product differentiation, which is very specific and stylized to illustrate the effects. But for empirical work, for policy implications, Hotelian model is not that useful. So for that reason, I would like to treat this study as a more in terms of methodology. That is, we would like to provide a generic, in some dimensions of model, a generic model, but at the same time, very stylized. So I would say general toy model of platform competition. So what is generality? That means in our framework, we allow many number of platforms, so not just two. And in terms of customers' response, so customers can choose one platform or the other, or don't choose any at all. So it's a typical discrete choice model of consumers' demand. Okay. So in this kind of discrete choice setting, for those of you who have worked on this set of problems, we typically, for example, use a logit model or nested logit or even more BLP framework. And here we allow general distribution of random utilities, we will see. And then moreover, we allow general form of externality across groups. So if you think about advertising problem, then you can specify a particular functional form, how users, subscribers affect, essentially number of eyeballs affect the advertising revenue and so on and so forth. But we specify very general functional form, as we will see. So along those three dimensions, those are general. But in terms of stylized, in the sense that, as we will see, we focus on single homing. We focus on one unit of choice, but variable number of units can be incorporated very easily in this setting. And then moreover, for the initial analysis, we focus on symmetry across platforms, okay? And other dimensions could be introduced into this framework as well. So as I said, we're trying to develop some analytical tools to analyze this general setting, particularly including equilibrium existence and the uniqueness and some comparative statics in terms of if the environmental parameters, primitives changes, what would happen to the equilibrium outcomes and so on. So with that, we can study what I just mentioned, the impact for competition, free entry, and merger reviews, and so on and so forth. Okay, so this is what we're trying to do. Although there's no MBA takeaway message, but I still like to summarize in case I don't finish. I think a general message from our analysis, which initially we found very surprising compared with literature like Mark Armstrong's paper, essentially in our framework, although general and specific on other dimensions, the prices charged by platform can be decomposed very nicely into three pieces. And the first one is obvious. That is, if there's a cost associated with the service, you're going to just mark up based on the cost. But typically, that cost is very low or zero in the platform setting. But at least that can be separated. And the second term is what we call product differentiation effect. This is a typical markup oligopolist or monopolist could charge because you are providing a service or differentiated service due to elasticity of customers' reaction to your price change. So that means without externality, in such a setting, we are in the standard oligopoly problem with price competition. What we're adding here is, since we're talking about multi-sided markets, since there's a cross-group, cross-size externality, that means there's an extra term in the price determination, which we call cross-subsidy, that we could help to compute to determine exactly what determined that cross-subsidy. And then we would like to illustrate in our generic but toy model, those three, or particularly the last two effects or terms, can be computed completely independently through primitives without interactions. But essentially we're pushing the boundary to what extent those two terms can be computed separately or have to be determined altogether. So I'll illustrate that. And so the third term, cross-subsidy, is the most important one in the context of multi-sided platform. That is, essentially, we would like to understand what determined that term. Positive, negative, how big that it is. Moreover, if we're going to study the impact of competition on prices, typically we know the product differentiation effect is decreasing, is monotone in competition. That is our traditional wisdom. That is, as the competition in the market goes up, the price will go down. That exactly that term. Unfortunately, typically in this set of markets, cross-subsidy also increases as competition goes up. So the net effect becomes less clear. That is why in this kind of setting, very often things get complicated. But we'll like to illustrate that. So we try to answer the free entry question, and we try to analyze the impact of a merger. So it's in the context of merger, we provide conditions to illustrate to what extent the outcomes tend to be different from the traditional oligopoly setting. That is the basic message. So back to my initial discussion, that is, in order for us to analyze any of those issues or provide real antitrust implications for merger reviews for collusive behavior and so on, if it's for merger review, we need to understand demand system and predict price changes. If it's collusive behavior, we need to estimate but for environment, what would have happened if the collusion did not occur. And no matter which counterfactual or forecast we're going to do, we need to understand to what extent subscribers' demand or in reaction to the platform service prices, as well as advertisers and publishers and so on. So estimating demand system is crucial for any of those analyses. Whether we have data or not, it is still a good idea to understand how customers make their decisions. So this applies to other settings like infringement of intellectual property rights. And if you did not infringe my product, and what would happen? So if we look at the difference, we will be able to compute the damage and so on. So I like to just provide a model. So again, it's a generic in some dimensions, but very stylized in another dimension. So in such a setting, we consider M platforms and S group of customers. So far it's very generic. And so since each platform is serving S size of customers, so that means each platform is providing S products. S times N is the total number of products we're dealing with here in this industry. Okay, and just consider 2 for each. That's fine. Okay, as you will see, between platforms, there's competition. But within a platform, since you are dealing with 2 sides, try to get the 2 sides on board. So that means the 2 products or 2 services you're providing for each platform, they are complementary. So for those of you who took industrial organization class, oligopoly theory, we're dealing with an oligopoly setting in which each firm offers complementary goods, cross firms are substitute goods. That's just as simple as that. Okay. Now, how do we specify customers' response to platform service? Well, typically in the discrete choice model of modeling consumers' choices, like automobile, breakfast cereal, and so on and so forth, we say, well, consumer, if such a consumer choose platform K or product K, you have some intrinsic value to it. Let's just make it symmetric so I don't put subscript K there. And I is the size, the customer from group I. Okay, you pay a price, and there's another part of utility which we depending on how you view that part. Consumers know that part of utility. However, from platform's perspective, from research perspective, that is random. So we typically use distribution and to describe the random variable. That is how we generate the demand system. That's the standard approach. So in other words, there's the intrinsic value and there's a price, and we call it random shock. Suppose we just ignore this complicated term here. This is a standard way of doing a discrete choice model in industrial organization. So if this epsilon is subject to, let's say, extreme value distribution, we have a logit model. If this is a normal distribution, we have a probability model. If this is some other distributions, you don't have a nice representation, but computational-wise, it's more difficult, but it can be done. Okay. What we're adding here to that setting is that each customer from each side, when you choose a platform, you derive certain utilities which depends on how many people participating from the other side. So this X here essentially is a profile of participation from other sides. So that means, with that understanding, that means your choice, a customer's choice, will depend on how many others are choosing. So you have this interdependent decision-making problem. If that is the case, then platform essentially will aggregate all the revenue profits together across sides, and this is demand, that's the price. And what we're looking at is sort of in the game, in the terminology of game theory, we're looking at the 2-stage game. Platform set framework, like fees and so on, and the customers react to that. Okay? So in terms of modeling, that is the page. So if we could solve this model, we can go home. And that is the problem. Okay? So let me just spend a couple of minutes to describe the analysis. But I did not try to specify in further detail about how those things, for example, how epsilon is distributed. We allow any general distribution. Okay? And this functional form could be linear, and some part could be 0. For example, if you are thinking about advertising through media, the positive externality could go one direction, but the other direction is negative. That is allowed it. So rather, this is a very general form. Okay, but if we take this setting as given, in any specific application that we're interested in, we can just incorporate a little bit more content to it. That is, in our application, in specific application, fee function takes certain forms. And given our data, I think epsilon is distributed by logit and so on and so forth, so that can be done. So in that sense, this is a diagram for two-side multiple platform, and we don't have to worry about it. So as I mentioned earlier, we focus on unit demand and single homing and full market coverage for the moment, and some of that, except single homing, could be extended, and multi-homing is a little bit more involved. And again, distribution can be very general. And what matters is the difference between your random utility and the difference between your random utility and the maximum of other options over a particular platform K. So that difference is H that will show up. Okay, so let me just, again, illustrate a little bit of the mathematics in terms of how we think about consumer's choice. That is, each user is trying to figure out the best option. And from a research platform's perspective, because you don't observe the random utility part, you compute the probability, which gives you a demand system. So the most crucial part of this setting is that every user's demand for platform K or product K depends on other users using particular platform and so on and so forth. Okay, so that means that is implicit functional equation. So it is very difficult to figure out certain properties of that demand system, and with that complexity, it makes it difficult to derive antitrust implications. That is why we talk a lot about different features of a multi-sided markets, but it's very difficult to conduct analysis as we do in the traditional single product, sort of standard product in one site setting. So the complication mostly comes from this area. Okay. Nevertheless, we could show existence, we could provide conditions for uniqueness for consumers' participation in equilibrium. That is, for any given profile of prices, we could show how the consumer's participation from both sides, from multiple sides, come together as an equilibrium. So as you can imagine, in the multi-sided markets, you might have multiple equilibrium. That is, everybody go to one platform, nobody goes to the other one, or they are evenly distributed, depending on the degree of externality. So we provide conditions for each of those settings. And then for price equilibrium, we could show, again, as I illustrated earlier, in this symmetric setting, we could decompose the equilibrium price for each side in terms of those three terms, as I mentioned in the beginning. This is the standard product differentiation term, and the extra one is cross-subsidy. So let me just go back to the literature that we're familiar with. That is, without externality, this is a standard model by Perloff Salop in the literature, which has been extended along many different directions. So this is the best way to link to the literature. But what we're adding is that cross-group externality. Okay. So with that, then we can do a lot of things. For example, in the simple setting, we could compute the prices exactly along, for example, Mark Armstrong's paper, where T are derived from the transportation cost, and the alpha is exactly the externality that it gives you the cross-subsidy. Okay, so here we show that the product differentiation effect is monotonic with the log concavity of a certain of the distribution of the random utility. And moreover, here we illustrate the conditions on which cross-subsidy increase or decrease with the degree of competition. So ignore those conditions, but essentially that's the effect. Now, let me just illustrate the effects by two examples. So the most commonly used distribution is extreme value or double exponential. So the product differentiation effect is decreasing in n in the simple form. And the cross subsidies also decreasing in N. But the net depends on the magnitude of beta and gamma. So beta is a description of a degree of product differentiation. Gamma or gamma bar, which is aggregate across different size. And essentially, it depends on the magnitude. So you can imagine if gamma bar is very small, 0, we're back to the normal situation. If gamma is large, then this monotonicity could be reversed. Okay? So based on this, then another example which I will not discuss. In such a setting, we could compute the platform profit, consumer surplus, or customer surplus for each site. With formula, you could balance as you wish. For example, you care about advertising's welfare more than subscribers or not, and also total welfare, total surplus. A key to this expression is this delta defined on the top, that is the product diversity effect. As the number of products increases or platform increases, consumers always benefit at diversity. So with this, we can do a lot of exercise. Okay. In the rest of the presentation, which I will not go through, we study the impact of free entry as compared to socially optimal one. So free entry in the sense that, this is a standard economics question. That is, if firms enter if the profit is greater than equal to fixed cost. Social optimality means that total welfare minus total cost is maximized. And so a natural question, welfare question is, if we don't have any control, is free entry socially optimal? Are we seeing too many platforms or too little? So in our analysis, we provide sufficient conditions, and we also provide examples to illustrate, particularly in the platform markets, you might have insufficient entry as compared to socially optimal. So that is the one application, which is more theoretical in that sense. And moreover, for merger review, there's a complexity in the sense that even if you start with 3 symmetric platforms, 2 of them merge, it becomes asymmetric. Okay? So the equilibrium problem in the asymmetric setting is much more challenging. And we are able to provide some numerical examples to illustrate the difference between multi-sided markets from the standard single-sided market. And I will not go through that. But the whole idea is to illustrate that if you have a merger problem involving multi-sided markets, I think we're ready to help you. So that's one. And then we could introduce outside options. We could introduce multiple units, which we did. And we have some results about multi-homing, but it's a little bit more involved. So I think I'll just stop here for questions and comments.
Hello. Yeah. So in the equation that you show, the price equals cost plus the product differentiation and the cross subsidy effect. So they are additively separable, right? These 3 effects.
Additively separable in our framework.
In your framework, and I would and it's a very nice framework. Very clean setup, a very nice starting point. But in empirical setting, people allow for consumer heterogeneity, things like that.
Yes.
And I would imagine with those more complicated models, then these 3 effects may not be additively separable, right? There may be interactions show up, or maybe you can say something.
Yes.
Say a few words on that.
One part of the paper illustrates that if you allow outside option in the discrete choice model, that separation doesn't hold already. And if you introduce other asymmetry, particularly in the merger context, that will not be true either. So in that sense, I was trying to say that this is a really toy model that focuses on symmetry, which pushes essentially what Armstrong did to the maximum boundary possible. Even in such a setting, we could do a comparative statics, how competition affects prices, welfare, and then we can talk about free entry. We can talk about merger analysis in such a setting. But the key assumption is the symmetry and full market coverage. Those are the two key assumptions. Yes?
Thank you very much. Very distinguished model, and I'm very impressed with your
Thank you.
presentation. My question is very simple, and it's too naive, maybe. But anyway, I'd like to ask you about what's the factor of the cross-subsidiary and the product differentiation. Both of them are affected by competition. If competition increases, the product differentiation will be go up, and also the cross-subsidy will decrease. So what's the maybe both of them are same factor of competition. So why do you differentiate the cross-subsidy and the product differentiation?
I would say first of all, ignore monotonicity, but the reason we're trying to separate it is that without externality, cross groups, which means we're talking about isolated single-side market. If, for example, desk computers and yoga and so on, that does not involve consumption externality. So that means there's no subsidy term. This is a standard way for us to describe price-cost markup. In other words, to what extent a firm, an oligopoly firm, price above marginal cost. The markup is determined by the degree of product differentiation across firms and by the fact that how consumers react to price increases. So that second term is typically decreasing as more firms providing similar products. Okay, so that's the typical case we're dealing with. But with multi-sided markets, if competing firm is trying to provide subsidy, and you probably would like to do as well, that is extra term. And to what extent competition would change that, which means that it would change the price. So what we're trying to do is by separating, it's easier to interpret and it's easier to compute. And of course, in the empirical setting, when you have a data, and those come together.
Just a very simple question. So you have a very general externality term, and do you also allow intra-group externality?
Yes.
Oh, okay. So in other words, your own group number can also affect. Oh, okay, good. Okay.
I have a quick question. So I'm a practitioner, so I asked the practitioner question. So there is a quite provocative paper a few years ago show that when you have two newspapers competing, and the monopoly, actually, the pricing is lower than the duopoly pricing because you tend to over-subsidy the marginal customers. And does your model accommodate this situation?
This can happen in that example. It can happen. For example, the distribution exponential, the product differentiation effect is flat. It's constant, as we know, and the subsidy term decreases with the number of firm increases, right? So, but because it's minus subsidy, so in that example, it already happened. So the question in that setting you're referring to is basically about the differentiation among the two newspapers is more likely to be subject to, for example, exponential distribution or something else. So that is accommodated in our setting. Although in our setting, that's a special case. So we have to look at the set of facts to what extent. I'm sure they did a lot of robust checking and so on. Thank you.